course. Oh my god. I hate this, dude.
Arfsog the Illus before? He's a good dude. He's a pretty smart dude. He's the leader of the e-ship community. We're just trying to make sure that everybody focuses on delivering. That's all. I've taken up way too much of y'all's time. I just wanted to kind of put that conversation out there. I appreciate you hosting this, Brandon. Thank you for letting me up here, Big Dog.
No, it's cool. It's a cool vibe that you bring and cool ideas. LJ wanted to say something, and I think Allison.
Yeah, I just didn't want to interrupt or anything. But yeah, like Technium and people like that. Like Technium is probably my closest colleague right now in news research, and we have like an organization, and there's another organization called Alignment Labs, which is doing stuff, and FARL has Skunkworks and stuff. But I would say there is actually things like Alignment Labs has a model, probably their flagship model right now, OpenChat, where you can actually use this in a hosted like website already in like their own network. And then it just like
Oh my god, this is the worst. I can't. Dude, I hate Twitter so much. This sucks so much.
As far as data collection and that distributed and for EACT, like that's very much news research doing a lot of that. I guess you're maybe distributed across because the cost of a centralized inference of language models is really expensive, and there's people working on that too. It's just
yeah, you're very smart in picking up on that. The reason I actually stopped at a certain point was I realized if I were to say too much more, that I'd be giving away some sauce.
I think everybody knows the sauce, though. You can. People have been running distributed inference with Raspberry Pi.
Yeah.
And they make nice products. I mean, you got the Sphere in Vegas. It's also part of the gambling and entertainment industry. Nothing wrong with that. It's just that when you're making an AI product, The incentive there is, one, to use a data structure which is the opposite of what the requirements are. So the requirements for AI are to have as little network overhead as possible. So they, whereas instead, a lot of these decentralized incentives end up using a blockchain pattern, which is literally the exact opposite of that. You're literally using the slowest thing possible with the most amount of overhead. So one is you're on a dead end technically, and two is when people use an AI product or they use a doctor chatbot and stuff, they expect to rely on it. They know it'll fail maybe once in a while, but they expect to rely on it. So as a user experience now, when they use a crypto product, they expect to just lose every fucking thing. Because again, it's the gambling industry. You know you're going to get a rug pulled, but you'll make money by the time you do. So you've accepted the odds. So the reason that decentralized efforts have failed is, one, they failed on the technical side, and two, they failed on the user expectations on the UI. So like just on a first principles basis, why we haven't seen that many of those. They'll happen though.
There are some that are currently happening too. Like they're not happening, and they're good too.
Yeah, so I just wanted to say there is already a decentralized inference platform that is actually like pretty good and is faster than a lot of people's computer. So they have a 70 billion, which is like that's 10 times larger than what most people are running on their computers right now. You can run a 70 billion parameter model on Petals. I think it's chat.petals.dev. I think that's the URL. And yeah, it's like a really nice interface. It's distributed inference, so it's running different layers of the model on different people's GPUs, like throughout the world. And it's surprisingly fast, like for what it's doing in terms of the distributed inferencing. And there's just going to be kind of more models that are using things like that, or probably things using pedals as the back end for their models. Yeah.
There we go, boys. Now we're talking. Now we're talking real shop here.
Now we're
right?
cooking.
Yeah. Now we're fucking. Now we're cooking with. Now we're cooking with uranium.
Well,
We're
that might.
accelerating now. That's what I'm talking about.
I don't think you also like. I mean, pedals is good, and I like pedals. I want more pedals. But in terms of like blockchain layers and how you can integrate that with getting inference from a model, like you can just build an incentive layer on top of like a different uh, like underlying technology and use crypto for what it's good for, which is transacting, and then use that to incentivize people to share the compute that they have available, as opposed to like trying to run it on chain or something like that, which there are
Sorry,
also
I mean,
implementations of.
you cut out a little bit for me. Could you summarize like that last bit, or like pretty much the main point at the end you were talking about?
Yeah, that crypto or blockchain technologies are good for incentive layers. So just build an incentive layer and use it to incentivize people to share their compute, basically.
Oh,
And people
okay.
are doing that.
Yeah, yeah.
I mean, in theory, yes, but the big but. Why isn't there a GoFundMe with crypto? Why isn't there a Kickstarter with crypto that's popular? Like
Because
that's a lot
crypto's
simpler than
brand
this.
is terrible.
Like
GoFundMe
That's
actually
a.
it gets
exists.
security issues, right? Like
Well,
I was gonna
GoFundMe
say,
actually
Niston.
accepts
I could
Bitcoin
actually.
now and everything. No, I'm kidding. No, they
I,
don't.
I can tell you it's 100% AML KYC money laundering issues. Right? People sending money over PayPal or Venmo, or people sending money with their credit card is totally fine. But if you just made a GoFundMe, it's like, I am sick child in Iran and need many bitcoins, please. It's like, okay, cool. Let's just send him a bunch of Bitcoin. It's like, no, you just like kind of like got yourself in some federal shit, right? So there's a big issue with that.
There are solutions to that too, like that only work in crypto and don't work outside of crypto as well. Like you have tools to identify people on chain as opposed to or like let people opt in to identification utilities that you can build on chain. Whereas the like GoFundMe, we trust it because like they are held to some standard by regulations. Whereas like you can build that in programmatically with like the World ID or Polygon ID or whatever. I think the real thing is like these things have been built, but they aren't popular because Web3 in general just has a really terrible issue with branding. Like everyone just thinks everything is a scam. So even if you build this wonderful technology that like is actually technology and not just like vaporware you're trying to scam people out of money from, it's really difficult to actually communicate that to people and have them listen.
I
All right.
think we maybe
Can I
transition.
request a vote for a halt on crypto talk and a return to AI
Works for me.
technology
Yeah.
and actual underlying technology talk, please? Thanks.
LDJ was going to say something.
Yeah, I'll just wrap up on the point since I agree with Farrell that I don't want to get stuck up on crypto stuff. But what I was gonna say is like KYC does exist, like somebody else mentioned, where like mechanisms for people that are using crypto or wherever to like let their identity be known to the provider or whatever. But just a lot of people in the crypto community or people using crypto in the first place, they don't want to opt in to identification stuff. So like that's kind of where it ends up not working.
Well, we don't even really need like crypto to do distributed compute, right? Like there's folding at home, there's like just torrents in general. But like, do you think we could do something like, okay, you train a very small segment of data on some batches, some number of batches, and then someone else randomly does the same thing, and you do a checksum to see if the small subset of the network that you're training actually is like validated. So you need at least like two people to like validate it. and it could be weighted based on how much validation it has. So if you have
But
a
I think it just
disputable,
gets into semantics of like at that point, like what is considered crypto and what's not. Because some people would consider what you just said to be crypto.
That
well, it's
exists,
like
and it's
it's
called
just not
backlog
crypto.
hell.
I think Farrell just mainly meant like not crypto currency. Like
For
I'm
sure,
not.
yeah. Well, I mean, like Farah was saying, yeah, let's talk more about like AI specifically, which I agree.
Yeah, distributed is coming. Like the distributed training is coming. Might be in a couple of weeks, couple of days, depends.
well,
But
I
it's not
think
gonna
what
have
It
anything to
exists. It's
do
here.
with the gambling and stuff. Yeah,
Yeah,
as
very.
Brandon said, people are just gonna volunteer there.
Brandon, you
For the
made a really
school.
good point about, and I think it steps away a little bit, so it falls right in line with what you're trying to do, Pharrell. And that is that it's less about crypto and it's more about consensus, right? And if you have um, distributed compute that is not infinite, that is requiring of work
Wait,
to be
why
able to
is
be
consensus
provided.
a problem? It's not a problem. Why what
No, I'm saying you could use
why are we
consensus to.
but do we need to use that? I mean, we could use quantum computers too, but
You could have 1,500 different devices all computing the same question from one person, sure. Or you could have a consensus of like
why do we need
the nearest
consensus for
neighbor.
it? Like, just use 5 devices. That's it. Problem solved. Like,
Well, you kind of need
The only
validate.
so there's like bit tensor, right? Like there's like that network that's trying to rent out GPUs in a distributed fashion, right?
Okay,
There's
there you go, done.
yeah, but like like you don't need a blockchain. You don't need
Yeah, I didn't think so.
that layer of a cryptocurrency. Like you don't need any of that. And also like just speaking from my own perspective, I believe that most models will run locally in most devices. Like the models are going to get so small, you'll be able to run it without any distributed inference or any API or anything there.
But
So
that's
like
just the current paradigm of inference is relatively
Yeah.
cheap.
yeah,
I'm agreeing with Farrell that like inference is definitely like project same
The
technology
model
for
isn't the
5 years.
endpoint, though, right? The model isn't the endpoint. Like we just said, it's also about, you guys were talking about it earlier, being able to store the previous conversation and reference it, right? What
I
if
can
that?
store it
What if
locally.
that?
Like
You
why?
know, that's a why store it locally when that information could be valuable to other agents?
Why would I store any information that I don't want to store? Like are you saying like all data is stored on the cloud?
I think
Like
he's just saying he wants an EAC like OpenAI that's RLHF'd on EAC stuff only.
Could I propose that you
Getting
want
getting
an EAC
okay, that's a
P2P?
different thing. Like I thought we were talking about the fundamental like way of deploying the technology.
Yeah, I want to get also down into like the
well.
details of how it can be implemented.
it's called a database. Like you shard the database in multiple locations.
Or you run it locally.
Yeah, like you can run a copy of the database if people want to do that. It's like there's a lot of imagining problems that don't exist in this area.
This is so aggravating, dude. Okay, I have to.
It's actually like when you go to sleep, it's like fine tuning a model, which I think is pretty amazing. I think like maybe something
I
like
actually
that.
set that up. It's kind of cool.
Sorry, oh, you just set that up? Yeah, I haven't
Oh yeah,
tried
I
it
gotta
yet.
set that up too.
But like, how crazy is that? Like, why do we like? Not to get too crazy here, but like we probably should have like, oh, when you go to sleep, your local device is fine tuning on your past conversation, so it's stored in the weights, not just the context. We can't just have everything in context.
Yeah, that's definitely something that's very Apple specific. Let me give a little bit of context on what that is. You can, by Apple's decree, do certain things that use some of the like specialized hardware that your device has by Apple's decree because you don't really have very much access to this yourself. And the fact that it actually does the training overnight is really pretty special. Generally, Apple doesn't give you that kind of access either. But what this does is it basically you read about 150 phrases, including numbers and some other kinds of things, and then you, under certain circumstances, your phone is plugged in, charging, blah blah blah. Your device is going to train this model, and so then when you wake up at some point, it took me a couple days because I didn't have it plugged in right, or I didn't have it. And it is kind of cool, but under very limited circumstances. That's kind of rough for me, but it's neat.
Isn't
the
that
guy
just
was the guy
11
was talking about
labs?
the concept. Yeah, the guy, I think whoever was bringing it up was just bringing up the concept of like you talk to your open chat or ChatGPT or whatever, and then overnight it fine tunes itself on your version of it.
Yeah, I
but
mean,
like
the
it's
concept
specific.
is limited though, because if you're gonna use some of your most powerful devices, like in my case, my iPhone is one of my most powerful devices. I don't really have access to do this myself. I can't write the code to do this. I can't access the hardware to do it. I could potentially maybe on my laptop. Um, that's not a bad way to do it. But yeah, I
But
think
you don't have
Brandon
to
was bringing up.
access. You don't have to write the code like other people in open source who are out write the code, or like, or whatever, or like even just like, the company themselves will write the code. But like the fact that it's like it's a possible concept in the sense that you can have like every single day, like on the 1st of January, you type during the day to your AI and it conversates back with you. And then while you're sleeping, then your system is actually training the AI on that day's conversation, so that even like even tomorrow when you chat with the AI, like it remembers all the knowledge from when you talked to it yesterday. And then you keep doing this for every single night, every single day. And then at the end of the year, like at that point, it's already been trained throughout all the nights on your entire year's worth of conversations, and it has all that knowledge.
Someone can correct me if I'm wrong, but I don't think you want to do that. Like I don't think that's how you use fine tuning. Fine tuning is for tone, not knowledge. So if you want it to remember what it is you're speaking with it about, or be able to use that information as context, you just want to develop a RAG system to pull that into its context
Okay, so
window.
I have a question on
But
that.
you
Maybe you can
can.
help me understand.
Mhm.
Like, how did you know how OpenAI does their periodic updates, and their latest knowledge cutoff is on April 2023? Like,
Mhm.
how do they incrementally add information?
Yeah,
Yeah, it's
LBJ
pretty
can
much through
do
fine
it.
tuning. Yeah, like you can add knowledge. Like I've done this. You can add knowledge through fine tuning. Like I've done it. I have colleagues that do this. It just like, yeah, like typically the easiest thing that you can do in fine tuning is like tone or personality, but you can definitely add knowledge. It's just different ways of doing it.
Sure. Yeah. I mean, my understanding might be limited, but yeah, that like, especially with the long context windows that we have, it's more productive to use RAG for that. Whereas you want to fine tune if you are trying to get it to like speak differently or kind of approach things in a different way, um, as
I could be
opposed to
wrong, but I
just pull
think
the info in.
LDJ actually invented RAG.
Fair
No,
enough.
I
You know,
did not. I did not
totally.
invent RAG, but
I think it's gonna be both. Keep in mind that the hard part about training and fine tuning is preparing the data. So that's the whole difficulty there. Is like, okay, you got a whole data dump of today. How are you gonna consistently take good chunks of it? Like actually just doing you don't really need too much technical skill for that. Is just how do you prompt it? How much, like how many words are you going to use? Like, that's going to take a while. And if you want to automate that, that's actually harder than like building the app. Kind of. That's going to take. It might even take more time. So that's the really hard part there. As to how do you find the right stuff to fine tune? How do you eval it based on what you had today? Maybe you don't want it to say your credit card numbers. There's so many edge cases there that's why that hasn't happened that much, because it's not hard technically to do. I mean, everyone fine tunes can use auto-tuner. There's so many ways, so many cool collabs. It's the engineering side, like the prompt engineer.
That's what
So
Apple. That's why I think Apple's gonna like fucking release their LLM. It probably might have like this sleep feature, something like that with good hardware integration that just like does it for you. It also obviously it will respect like credit card information. Like that's the stuff Apple like deals with every day. Yeah, go
I
ahead.
think
But
what
Niston, are
we're
you describing almost like an LLM powered ETL job kind of thing?
Yeah, they're gonna like change their whole like they're gonna have like a custom CPU that's gonna do all this shit. I mean, I'm just guessing, but I'm like very sure at least I have some conviction here for some reason.
So when it comes to like oh like credit card number, maybe you don't want the model to know your credit card number. Like I think that's just kind of overcomplicating things because at the end of the day, if I'm talking to like let's say I talked to Niston yesterday, for example, and then like let's say I have him hired as my assistant, right? And like I tell him my credit card number and then like now he knows my credit card number like like I don't expect him to just magically forget about my credit card number because like a day has passed like I think as long as the person is just interacting with the AI, like assuming it will continue remembering everything that you tell the AI just like you assume that a human is, then like I think it's not really that hard. Like this is already a thing that me and other people have like talked about, and I think for the most part the engineering challenges of it are like fairly trivial. It's just we haven't worked on it because we just have other shit that like we prefer to work on. But like theoretically, like this is something we could just focus a week on and already have it pretty much going. It's
I,
just a question of like how well will it be able to follow conversations with knowledge from a week ago, you
no,
know?
I think you misunderstood. I did not want it to have that specific information. So,
No,
so
no, I
again,
understand
yeah.
you don't want that, but I'm saying like I think a lot of people would be fine with anything you tell the LLM, it would remember continuously. Yeah.
Yeah,
I would
so
Yeah, I mean,
buy that.
they would until pushed. Niston's point about it not remembering your credit card, that's a good one. You don't want it to accidentally say that.
I
And there's
mean,
a bunch of stuff you don't know that you don't want,
yeah, I
right?
was talking in general, like what about the stuff you don't want the model to have? How are you gonna filter that based on that person? And again, yeah, it's just gonna be a lot of like semi-mundane work, but it's gonna take a lot of back and forth. I was trying to do summaries and I thought, okay, it's just a freaking summary with emojis. I've done summaries before. No, it took me like 8 weeks that I was doing them for these clubhouse rooms because sometimes people wanted the takeaways that everybody says at the end of the room, and then they didn't want the speakers' last names. They liked the emojis, but some of the summaries were too long. They wanted some debate, but not too much. That took me like 8 weeks to until get it down, and there wasn't much uh, technical there. Like to get something that's
Yeah.
consistent, it's hard, man. It's
When it comes to like sensitive information, though, I would say a lot of that is already solved actually. When you just look at like the current open source systems that are already built out for managing pre-training data, like if you look at, you know, what like Together and Red Pajama dataset does, like it's when you pre-train a model on all that data, you're not going to get something accidentally spitting out people's credit card numbers, even though that stuff is on the internet, because they have like massive scripts of stuff already made and made public of things that will automatically remove like potentially sensitive information that you usually wouldn't want the model to say, like credit card numbers, like full names and identities, addresses, like all of that stuff is scrubbed. So you could just implement that same code to scrub similarly sensitive data for the personal model.
All of this stuff is like technically so doable. And there's like a bunch of stuff that we all want to work on. But all of the concerns that Niston's bringing up and the solutions that LDJ is bringing up, like these are all product decisions. Like what you need is like AI community needs people to say, like somebody who's owning this product to say, it cannot show credit card info. It cannot have last names. It cannot like to give a bunch of these rules, and then we as engineers or as like users or whatever can go and like talk about all this and make like those kind of hard lines mean that we can actually go do stuff because there's so much that we need to that could potentially be thinking about, and that product person
Couldn't you
is what makes
just
it happen.
Couldn't you just store them as secrets instead of removing them and then having to add them back or later
The
or filter them
particular
out?
solution is besides the point. There's so many ways that you could solve
Yeah,
this.
I get what you're saying, Roman. I think I mean, the solution ultimately, like, if, like I said, there's other projects that I just think are like slightly a little bit more worth the time. But like, if I wanted to do it, I think the most a reasonable way would just like do those bare bones basics of the having it training at night, just training on your conversations in the most optimal way, etc., and then just having that open sourced, and then people can create their own forks from there. People can even implement the open source code into like their own fork that they use for a private business model that they end up productizing into like a really easy to install software, and then they can do all these things like, oh, modify the training code so it doesn't have credit card information and this and that. But we just need the bare bones fundamentals to actually be like developed by a couple people in the first place and put out into the open source.
Oh,
I
guys,
think
You're
also
breaking
sort of
news.
touching on a special point. Yeah, go
I
ahead.
got breaking news.
Oh, Gemini
Uh,
released.
no, go to
No, I'm kidding.
get.meme. .meme domains just went on sale. Just saying.
Oh wow.
Oh, that is actually kind of breaking news. Yeah.
Okay, let's back to LLM.
Okay.
So the interesting point that LDJ you bring up is that not just like AI, but specifically open source AI needs product, right? It needs product decisions. Like the difference between an LLM that can chat and ChatGPT is that ChatGPT is a product. It's got customers, it's got expectations, it's got UI, it's got a lot of those things. And somebody is trying to sell it to people. They have business cases, they have an analysis of what it costs and who might be the actual clients that would pay and what kinds of features they might actually pay for. All of that is what decides how something actually gets built. Otherwise, it's unconstrained, right?
Yeah. Are you familiar with AutoGPT?
Yeah.
Yeah, so like you have AutoGPT that was made as an open source project, and like that's like the core fundamentals of things, but it's not really like a very sleek, easy to use thing. And then somebody came around, made something called Agent GPT, and it's pretty much just a fork with a nice UI laid over, and then some like tweaks made to it over time, and then made as like its own productized thing that you could pay monthly for, and this and that, and then even other derivatives. But I think that's pretty much the best model to replicate. Like have the bare bones kind of, technology and functionality made out, and then allow just others to make forks and productize them in the best way they see fit, stuff like that.
Yeah, that makes a lot of sense. There's a lot of ways to go about this for sure, but I think that that's a core thing that needs a bit of attention. And it's an interesting point, I think, because I don't really see a lot of product people getting super excited in the AI space unless they're tied to a company.
Yeah, I pretty much agree. I actually used to be much more product focused back in my other company, which ironically we actually did more proprietary AI stuff. Or maybe not ironic because that makes sense for product stuff. But now that I'm working in open source things, I mean, I don't want to like, self-advertise or whatever, but like with News Research, we're working on a product called like News Forge, and that's something like a commercial product that would be actively implementing our open source stuff. And then I know Alignment Labs, they already have actual pretty nice product that is just not advertised much. I think it's called, if you look up openchat.team, I think is maybe the URL.
I posted the
Yeah.
link, on
Oh,
the
openchat.team.
I posted it on the Jumbotron, like the
Yeah, and so like
third one. Yeah.
openchat.team, I would say in a way it actually even has better functionality than the ChatGPT interface, because you can even like store multiple system prompts instead of having to copy and paste them from your like computer notes or something. You can like have threads and like indentations of different conversations and forks. Like, yeah, there's a lot of different possibilities. And then beyond that, it's like just as sleek as the ChatGPT interface. So
Okay, back to this, because this is what I was using OpenChat.team for the last couple of days, and again, it has more current answers than GPT 3.5. So I was trying to compare. It will give you more recent code. The code snippets are actually better. Or for example, for React, it's not going to do like older this dot or like more class-based stuff. It's going to give you more functional components. So it's newer. I prefer that. It's just, again, remember what Iam was saying a while back? Like he kept asking like months ago, like how does ChatGPT follow the prompt so well? Like that's one thing we haven't quite cracked. We need to do much better prompt pre-processing, and we like because that stuff is still behind. Because I already feel like in this case, OpenChat is smarter, has better information. Uh, in some cases than ChatGPT 3.5. But 3.5 is still much better user experience because I
I
can
think
keep
it might
talking to
go. Sorry, yeah, I didn't want to cut you off. I was just gonna say I think it might be because like bigger model, you know, like more layers and deeper model. I think that's where it kind of gets like certain emergent properties of following instructions a lot tighter than, whereas like we have a really, really good 7B model that's fine-tuned really well to where it's like smarter in most cases, but in terms of that in context learning, it's just not able to like precisely be following instructions as well, I think.
yes.
The
I
higher the
don't.
context, the higher the context length, the more the model needs like more memory, more parameters to get better context of what you're actually saying, I guess.
I thought the same, but like, I tried it with the 70B. I tried the Solar. What's the one from the Korean team that's on Poe?
Yeah.
So I
The
used that one as well. I used that 70B. I also tried Hugging Chat because Hugging Chat has the regular Llama 70B.
I think what we need is open chat to make a 7DB version of like the same thing that this is, and then or like because I feel like a lot of these really soda 7B models, they don't really have 7DB versions yet.
Yeah,
So
but it
yeah,
felt the same though. I tried the Solar one. I tried plain Llama 70B. I was getting the same experience. It just wasn't. It's just not following the conversation. It's missing something
The
in the
reason
prompt reprocessing. Yeah.
the
They have something else, and
the reason for that, from my understanding, is that managing like a long context window like that, which essentially the whole conversation is the prompt, but the problem with once you get to a long enough context window is the attention heads can't manage it in such a way where they can pay attention to the whole thing. They can only pay attention to the first and the last. There's been like some research on how to fix that. The one that comes to mind immediately is, I believe there was something called like a lambda mask where they changed during, I believe it's during pre-training, they changed how they were masking the reward state, um, and we're able to get much more consistent behavior across a long prompt. But and I'm assuming that's sort of the methodology that OpenAI is taking, or they're doing something. But that's why you're seeing that commonality between all of the models, is because it's just a function of how the attention heads are performing in long context
to
Well,
add on to
situations.
the heads thing, I know with Anthropic actually had some research. I want to say it was like within the last 6 months, they were doing some research into in context learning, and maybe like they were doing some mech interpret research to see like maybe what mechanisms are possibly most responsible for like increased abilities for in context learning. And then sorry, let me cough real quick. And in this research, they seem to show that adding more induction heads without really increasing the overall parameters much of the model overall seem to significantly improve the in-context learning abilities. And so it might just be a matter of like for the same amount of parameters, the parameters are just more focused on having more induction heads maybe for the ChatGPT models, for example, compared to like what Llama architecture typically tries to do.
I don't know what induction heads are in terms of like key value, but Farrell probably has some points here.
Yeah, I was just gonna like I think there's probably more tricks as well, just in terms of the way that they're training the model itself, like even during pre-training. I don't think it's as random as the like in context learning is one way, but also just like the like planning out of the actual training run could in a kind of curriculum learning kind of way could actually lead to potential performance boosts. There's also potentially just like tricks when you're like in the okay, like here's an idea, right? Like if you if you have a way to label the quality of examples, right, of the input data, you could like create kind of like this prompt format that is hidden from the user, but that preconditions the model to output a specific type of output. So like with that, you could have even more fine-grained control over how the model uh, like generates its output. So like there's probably a lot more going on than just the GPT-3 paper, right? Like there's a lot of kind of tricks that they can do without necessarily like changing the architecture of the model itself.
Or they just like it's very easy to just mention in one sentence something that they're doing and reveal no details about it, when all the secret sauce could be in the details.
I find I struggle with that a lot when I'm reading like an archive paper and like trying to like replicate it or implement it somewhere. It's like these little things that they pass over in like one or two sentences are actually like the exact thing you need in order to try and actually implement it somewhere. So I would my view or like the way that I'm seeing it so far is that there are a lot of optimizations like throughout the whole pipeline that aren't getting used, or like some models are using some of them and some are using others, either because they don't know or because it's technically infeasible or because somebody released it but didn't realize that they released like not enough to actually use it, or did realize it and did it intentionally. So there's like a lot of this fragmentation, which kind of sucks. Like because what it results in is us as the open source community not having access or like not being able to implement a given soda model that's actually soda, because the innovations that are happening so quickly are not like documented and centralized in a manner that makes them easy to like play around with and implement. So it kind of sucks.
Well, to add on to what Farrell was saying about things like even outside of the architecture, I was going to say that I think one of the most obvious things is probably the fact that they probably just have much bigger, like we might have the same quality fine-tuned data sets as they probably do right now, but they have much more of that data. Like even like I mean Hermes is not even super filtered for quality stuff, like, but that reaches just barely like around a billion tokens, whereas they could have like I could imagine something even just 10 billion tokens could have like significantly better results, or even like the data sets I work on, we've seen kind of clear correlation of even like a very high quality kind of 30K data set, like having just more data, like 10, 50 times more data than that, and fine tuning does give significantly better results. And yeah, I think it just might be like one of those types of things, along with something like curriculum learning, like Farrell was talking about, and other non-architecture things. Yeah.
Yeah, because I think a curriculum is like. Wait, who was mentioning a curriculum learning? Farrell.
Farrell was talking a little bit about that.
Yeah, I think that's like super key. Because like, yeah, I don't think there's any guarantee that the models like converge or learn the right way necessarily. So it's like, if it learns something the wrong way with garbage data, like sprinkling in a little bit of good data might help a little bit, but it might still be fundamentally not set up right, and you need to completely do way more compute than was ever done to get it to that point to fix it.
Yeah, I mean, even just in data cleaning, though, there is like a lot of little tricks when it comes to pre-training and data cleaning. And when I say like a lot of little tricks, I mean little tricks that are even already applied to things like Llama that are still kind of kept like somewhat secret. But like there's a reason why, Llama and Llama 2 are like very ahead of everything else. And then the people in Mistral that created a way better model, they just happen to also be like one of the lead members on the Llama team previously. So like I mean
I don't know.
there's I mean these things are not a coincidence, I think, and there's a lot of little tricks that they talk about where there's a lot of nuances that go into these things. Where the stable LM people, when they tried to even do a 3B model, like I mean, people were making fun of them. It was so terrible. And then about 6 months later, now they have like one of the world's best 3B models, like almost approaching 7B.
Wow.
And
So they probably have like some institutional secrets now.
yeah, I mean,
Or
like I know some of the people that joined on their team and some of the people I work with and stuff, and I just imagine it's really that like experience and a lot of little tricks that you know from experience and things like that that you end up just putting into practice. Yeah.
I almost feel like I'm not sure if it's true, but like tokenization is kind of like one of those like tricks. Like I don't think it's really strictly
I
needed.
believe it is.
Like
Yeah, I think
like
I
you can just
remember a paper.
because you can't you just do like single character token and it like, in theory it should
Yeah,
be
but
able to.
But that stuff is public because we know exactly like what tokenizer any given open source model is using, and then like you can directly just interact with the model and see exactly what the tokenizer is. So there
yeah,
can't be
but
many
they can
secrets.
still do tricks. No, they can still do tricks because you can like add uh, like uh, like layers between the tokenized like the tokens that go in and the actual like input for the model, right? And you can process you can have like a processing step that is blind essentially, like and that would mean that you like anything we say is basically speculation at that point. But there is there is an argument to be made for better tokenization strategies because current way of doing it is like is pretty shit. Like honestly,
I
like
mean
if
you
you
can
look at
try
just
to
the vocab
a little
size,
contrived, right?
yeah, just look at the vocab size of like the vocab.json of any model, right? Like it's ridiculous. I think there's definitely a like some tricks there that we haven't found.
I think it's confirmed that at least GPT-4 tokenizer, I want to say, is like at least 200K like vocab size, whereas Llama is only around like 20 or 30K last I checked. So
It's
It's
there definitely is a discrepancy there, and it's not exactly like it's definitely not just as clear as more is better, but I mean, like there's something there that is maybe tells us something about like the layers of how the model is architectured around the tokenizer, you know?
Yeah, but
And maybe
LDJ,
that's
like
it.
200K tokens, like is that just back like how did they figure that out?
So like there's some people I forgot exactly what the library is called, but there's some GitHub project
Tick
that
token,
basically
right?
like reverse engineers the tokenizer for
Okay.
ChatGPT through like sending a bunch of API calls and stuff of like
They
the
guys,
and
they open sourced OpenAI open sourced their tokenizer. It's in a library called Tick Token.
Yeah, tick
no, I
token.
Um,
think that's the old I don't think that's an official implementation tick token, but that I
No,
think
it
that
is.
is like one of the things I was talking about.
No, it is
Um
a visual implementation.
oh okay.
and I think
Um
they say that the tokens consumed in a request should match that. Yeah, but I use that a lot.
Yeah, but
So
what I'm trying to get at is that it doesn't matter, like it doesn't mean that oh it's token like it's tokenized and with like the whatever's available with tick token that it is what the model consumes and learns. Like there
Oh,
could
I
be
don't
an
know if it's
additional
that, like
step in
maybe it's
between.
not what it's learning, but at least at inference time, like for that tokenizer, like that tokenizer has a vocab size of like at least 200K based off like people interacting with the tokenizer and then getting at least like 200,000 different unique tokens that they've been able to identify. So we know it's like at least that amount because people have been able to identify at least that amount of unique ones. So it might be much more than that even, but yeah.
that, and OpenAI's methodology for making a tokenizer isn't necessary. Like there are other methodologies that people are using to create their various like alternatives to tokenizers that sometimes are at least perform differently than ChatGPT, better or worse. I wouldn't want to say, but like for instance, AI 21's Jurassic, I believe the way that they structured their tokenizer was they use both like character level and word level and sentence level in some sort of combination to kind of give it I think it's for their like storyteller model that makes it particularly good at interpreting and then generating like scripts and movies and things like that because of the tokenizer is structured in the same way as like the corpus of data of scripts and books and things like that for entertainment purposes. But that's just like a random example.
Has anyone tried training an LLM on just single character, or just like like UTF-8? It's like 8 bytes to like, it's like, sorry, 1 byte to like, is it 1 byte? Yeah, one to like 4 bytes or something. Just like make everything 4 bytes, every character, whatever you want. Just plugging
Well,
it.
I
Like,
mean,
does it
like,
not take off? Does it not? Sorry, I just want to. Does it not like get to the, like? Does it get stuck learning or something?
No, you can try it with Nano GPT, the Karpathy repo, or like he's got like a video with like a simple language
Yeah.
model, basically like a GPT architecture. And his encoder, like his tokenizer there is basically just a character level tokenizer. So
Yeah. So
you,
why do we even need like multi-character? It
well,
might save a little bit, like you can fit a bit more in the
it takes in
context, but
context
well,
versus.
because like it gives better. It might take off still if you do like the way you're talking about, Brendan. But it's just found that this like seems to be more optimal way of like learning faster and learning better, like for the same amount of training and everything. You know.
It is a bit counterintuitive because like it basically means that your like search space is um much wider, right? Like you have to kind of like your next token, which is like your next action, right, is out of like 50,000 tokens rather than 30 or whatever, however many you want to represent, right? So like there is a like I do see the
like
point
that's why
with
it's good,
that.
right? Because it's like it's helping the LLM like process a little bit less.
Yeah, but also at the same time, it might not be like representing the data that it's trying to compress in an optimal way.
Yeah, and LDJ, to your point, like, yeah, it's gonna take less time to train that because you've jump started it, right? But do you take into account the time it took to get those, like that token to embedding, initial embedding, or just the tokenization strategy or whatever? Like, there's still some processing going on there, but
Yeah, I think like, that's a very minority part of the like if you have 277 if you have two 7B models, one with like a 10 times larger tokenizer and then the other one with like 10 times smaller tokenizer, like the difference in overall speed during training, it wouldn't be that significant. Like the tokenization part of training is like it's a very, very small portion, especially when you're doing pre-training.
Are you
okay,
pretty
okay.
confident about that?
I'm
I,
pretty
I
confident, yeah,
mean,
because like usually before you do like pre-training or even a lot of fine-tuning runs, you do the tokenization step first. You tokenize the entire data set, and then you do the training off like the already tokenized data portion that you just made. So that step of like tokenizing the entire data set first is like a very small amount of time compared to what the actual main training portion
well,
takes.
it makes sense because like the transformer is like, it's sorry, yikes, I'm just gonna temporarily mute
Oh,
you. I
sorry,
think you
sorry.
can just unmute just because your mic was on.
Yeah,
But
you're good.
the transformer, like it basically, if you just give it character level, it's like learning to spell on its own kind of thing. And this kind of ties into like maybe the curriculum thing. So it's like if you do character level encoding, like you might need to start it off a lot slower with like very basic examples so it can pick up on that. And the other point I was going to make is that like LLMs will have to unlearn those tokens anyways. Like for example, if you ask like the ing, I think is one token, but if you ask GPT, oh, what are the letters in ing? Oh, it's I, N, and G. It gives you a separate token. So how did it learn that? Well, it's because it learned that ing was maybe in its training data, it has those tokens in it, right? So it already has that knowledge of what is inside a token. So it's just that it probably learns that way later instead of way earlier kind of thing.
It's a very interesting thought, actually. Uh, makes me wonder what's the point of going back to that, like going with that level of complexity.
Like you mean the tokenization, like why we should
Yeah,
even be using that?
why should we go to that level of the complexity? I guess I've got my reading list for tonight, right, is to figure out read up some papers on that.
I think, yeah, I really curious to see what you find, but I think the answer, just a speculation, is that because we never tried LLMs with like massive compute training runs, the ability to jumpstart a model is like really, really important, especially when we're just trying to like validate results early on. So it's like if you
Sorry,
can,
can you repeat that? What do you mean by massive compute training runs?
like,
Because like Llama is trained on like massive amounts of compute.
I just mean like tokenization was around in an era when, well, it's still around, but like when LLMs or when transformers were still new, you wouldn't really get that great a result maybe just by doing single character tokenization. I might be wrong.
Okay, yeah. Yeah, I'm not too sure about that either. Yeah, I think there is probably some studies we could find like that were made in the past 2 or 3 years that probably talk about like single character like tokenization and stuff like that. But yeah,
Well,
I
in
guess
the
yeah, it is like, somewhat not lost knowledge maybe. Like yeah.
like in the original attention is all you need paper, I'm trying to remember if they actually mentioned tokenization all that much or
Were
what
they even
exactly was
using it
the
for language modeling in that paper? I'm not even sure. It's been so
yeah.
long since I looked at that paper.
Yeah, I'm not sure actually. Maybe they don't even imagine they don't even mention tokenization. They're just doing, and that was just an
Yeah.
invention for.
I mean, and like back in 2017, there definitely wasn't even really an LLM that was even smart enough to have like very basic conversations with much. Because I mean, ChatGPT is kind of the first one that was even able to like really do that to an extent. Yeah.
Yeah, I think the paper GPT was like the first one to like kind of make a chatbot. They're like, oh, just do RLHF and like scrap the encoder. We're not doing translation. Let's just. Someone had the brilliant idea to do that at OpenAI. I guess.
I think there's also like on that note of just things that seem like relatively basic, like even the whole fine-tuning aspect of the whole procedure of like, oh, you're going to pre-train the model on data, and then you're going to like have a different set of data that you fine-tune on for like the specific task you want and stuff. Like that was pretty much, I think the work is called ULM fit, but that was something pretty much like Jeremy Howard and a couple of other people just came up with. And for the most part, everybody for even like different types of architectures are pretty much just using that same type of training procedure.
Yeah, I'm thinking like I wonder what would happen if you have like something like llama or whatever, and then like you just freeze the early layers and then like retrain it with like character level encoding, and then maybe more training to like merge them together or something. Like maybe the early layers in the transformer are just like, well, maybe you need to add more layers because we need more layers to do the work of what the tokenizer was doing or something like that. There's so much possibility for research.
Yeah. By the way, I was just kind of like fact checking myself real quick on, like how much of the overall processing is taken up by tokenization. And it's like kind of hard to find specific numbers on people testing this, but at least for BERT, it was found to be at about 1% of the inference time is taken up by tokenization, apparently. So
Oh yeah, but then there's like, how do you get those tokens to begin with? Because that, if we're talking about we want to do single character encoding, that's now going to be something that has to be trained. So that it would make sense to include however you got that token scheme.
oh yeah, like to derive the tokenizer in the first place, that's like its own like separate thing, yeah. But once you like derive the tokenizer in the first place, then you can use that for like whatever models, and you don't have to like redo that entire computation of
Yeah.
essentially training the tokenizer. Yeah.
Yeah. Sorry. Yeah, I get what you're saying, but I'm just saying instead of doing that, we could just have like instead of like, oh, these large chunky